Hi guys, welcome to the second video, and today we're going to talk about the volume of a right solid. So around Valentine's Day we talked about geometric solids, which were essentially the three-dimensional version of things like polygons and shapes, and today we're going to talk about finding the volume of those. Specifically, we're going to talk about finding the volume of right solids. So a right solid is a geometric solid whose sides are perpendicular to the base. Here you can see a rectangular prism that is a right solid. Its sides, these faces, are perpendicular to the base and the top. And here's a triangular prism that's also a right solid because these rectangular sides are also perpendicular to these triangles, although it's a little bit harder to see. This one, on the other hand, this geometric solid is not a right solid. It's what's called oblique because these sides are not perpendicular to the top and the bottom faces. Did we have another term for solids like this and like this? I kind of used the term. Maybe you heard it, maybe you didn't. But these are called prisms. They have the same congruent shape on the top and the bottom on two of the faces. Like here it's triangles, here it's rectangles. And then the other sides around these faces are rectangles. You might be wondering, are all right solids prisms? What do you think? Here's an example of three right solids. Are these all prisms? Well, in this case, these two cases, we have things just like we saw before. And I told you that, yes, those were called prisms because they have the same congruent shape on the top and the bottom, and the sides were all rectangles. However, this cylinder, we wouldn't really call a prism because although it has a circle on the top and the bottom, the surrounding area, or the surrounding surface area, is not made up of rectangles. So this is not a prism because it's not flat on the sides. So let's talk about volume. We have talked about the volume of cubes before, I think. And the volume of a cube was just easy to calculate. We would just calculate the side length to the third power. We would just, in this case, do 5 times 5 times 5 and get 125 cubic inches. But what about a non-regular right rectangular prism? Just like if we were calculating the area of a square, we would do side length squared, or side times the side length. Compare that to a rectangle. Instead of squaring the side length, we would have to calculate it by multiplying the length times the width because those might actually be different. So you might be having an intuition right now that instead of multiplying 5 times 5 times 5 and being able to do s cubed or 5 cubed because they're all the same size, you would multiply the length times the width times the height. But for a non-regular right rectangular prism, these are all different numbers. So in this case, the volume can be calculated by multiplying the length times the width times the height. In this case, what would it be? 12 times 4 times 3. And can you calculate what that would be? Pause it if you need a little bit of moment to calculate, but that would be 144 cubic inches if this were inches or centimeters or whatever the measure is. In general, the volume is the area of the base times the height. So if you take a look back at this one, you could think about calculating the area of this base, which would be 4 times 12, and then multiplying it by this height. You could kind of think about it like this. Here, this 4 times 12, that was the area of the base times the height. So which side is the base? It's not always on the bottom. and the orientation doesn't really matter, right? If you took a cylinder, for example, and you rotate it around in the air, you're not actually changing the volume of it, right? You're just changing its position and orientation. So, for example, these are the same three geometric solids here and here. Obviously, the size hasn't changed, so the volume shouldn't either. In this case, you might think that this bottom part was the base, whereas in this one, it looks like this is the base. So which one's right? Well, in the case of a rectangular prism, it really doesn't matter that much which way you consider as the base. But for things like a triangular prism and a cylinder, what you can tell is the base is the thing that's the same on the top and the bottom. So in this orientation, you can see that the triangle is on the top and the bottom. It's not a rectangle. Those are parallel planes to each other. That's the base and the top. In this case, for this cylinder, you would say that these circles are the base and the top. Okay? In any case, you don't really know yet how to calculate the surface area of the site. So hopefully that's not going to be too confusing. So we know that our overall volume is just going to be equal to the area of the base, and that's for prisms, it's the thing that isn't these rectangular sides, times the height. So let's take a look at this picture. Here we have a triangular prism. And first you have to figure out which two sides, which two faces are actually the base. So hopefully you figured out that it is these triangles. So let's just think about one of them. It doesn't really matter which. They're congruent. They have the same area. And let's just think about what is the area of this triangle. Well, we know that the area of a triangle is 1/2 of the base times the height. I'm using the same word base. Don't get too confused whether I'm referring to this triangle or this geometric solid as a whole. But the area here would just be 1/2 of the base times the height. Remember, the base and the height are just two measures of a triangle that are perpendicular to each other. One of those has to be a side of the triangle. The other one doesn't have to be, but it may be. In this case, since it's a right triangle, the 3 and the 4, it doesn't really matter which of those we call the base and which the height, but we're just going to multiply those together and divide by 2. So in this case, 1/2 of the base times the height, the area of this triangle would be 6, and that would be 6 square meters. Then we need to multiply that whole thing by the height. Now it's a little strange because this prism's actually laying on its side, but the height is essentially the length of these rectangular faces. And you can see here, that's 6. So to find the overall volume of this shape, we would do 6 meters squared times 6 more meters. So we would get 36 cubic meters. What about this cylinder? What are you going to consider the base in this case? Hopefully it's easy to see that the base, especially since it's standing upright on it, is each of these circles, although they look like ovals because we're viewing them from the side. So how do we find the area of a circle? Remember that the area of a circle is just pi times the radius squared. In this case, it will be pi times 4 squared, or 16. We can just go ahead and leave pi in our answer. That'll make things easier. And so our volume then is just 16 pi times the height, which in this case is 10. And so our overall volume for this will be 160 pi. The units for that are cubic inches. How about something like this? You can also have geometric solids that are not very regular at all. But as long as they're right, meaning that these sides are all perpendicular to one another, you can still go ahead and use the same strategy. In this case, The face that's the two faces that are congruent to each other are this kind of L-shaped thing that you can see here, and that is also in the back here. So when we think about the base, we need to figure out what is the surface area here. Now, we've known from other lessons that we could, for example, break it up. We could calculate this rectangle here and then add it to this rectangle here. We could think about a large rectangle like this and subtract out these missing components. But for this one, it's easy enough to just count. So we have 1, 2, 3, 4, 5, 6, 7, 8. Our area for this side is just 8. And then if we look to see how deep it is, or what the height is in this case, it's 1, 2, 3, 4. So if you're trying to make this shape out of building blocks, you know that you would need 8 times 4, or 32 blocks. Okay, I hope that was good. See you next time.